my talk today is really to walk through some of the work that we've been doing in this space, but also to review, I think, where we're at the moment in this field and some of the gaps that are in the knowledge. When we think of athletic performance, it's a broad spectrum, a large continuum between the individuals such as the sprinter or the bodybuilder, the power athlete, the strength or hypertrophy-driven athlete versus the endurance runner. And the reason I mention this is because I think it's important to put context around what we mean by athletic performance. So in science, we tend to often work in these extremes of the kind of explosive, or as I said, strength-based athlete versus the endurance or the marathon-type athlete. But if you look at the types of sports that all of us watch on television to a large extent, and maybe a lot of us compete in as well, and personally what I compete and consult in, it's in the area of team sports. These are unique athletes. They are striving to optimize body composition like most athletes, but in particular they're looking to maximize strength and power while minimizing, I would say optimizing body composition from the point of view of dropping body fat. So clearly dietary strategies that influence those elements are important. That's I would call those indirect influencers of performance. But then also we need to think about the actual acute fueling that goes on around exercise sessions and competition itself. So So this is kind of what I was getting at as I was speaking there. So back again one, sorry. So ultimately we've got a number of different strategies that we use in performance nutrition when we're trying to enhance performance. And some of these relate to, as I said, these indirect type of performance influencers, which are things like speeding up recovery, meaning that we can get more out of subsequent sessions. If we get more out of subsequent sessions, in the long term we develop a better adaptation to training, so that's greater gains from training, looking at improving muscle mass and reducing body fat, as I said, strategies around reducing illness and injury. This direct influence then is what we, as I said, what we eat in and around, or how we fuel in and around training sessions and performance. So ultimately all of these combined are how we enhance athletic performance. Next slide, sorry please. Now, the other thing we can think about is the nutrition cycle, and again, the reason the context is important here is because we're talking about how we fuel in and around training sessions and competition, but also what we do in terms of recovery and our habitual daily intake. So, although this particular slide shows several different phases here, I suppose this is what we consider in time. This is the longest in the sense of this is what we eat every day and the food we consume on a weekly, monthly, yearly basis. Whereas these are the things that we do in and around training and competition. So, for example, the philosophy around the pre-training meal or pre-competition meal is that we're looking to minimize gastrointestinal disturbances, top up fuel stores. Traditionally, this has been using moderate glycemic index, high carbohydrate meals. During training or competition, you're talking about the fluid or food consumed. Again, typically this has been a high carbohydrate gel or a sports drink, for example. And then in the immediate post-exercise recovery period, so we're usually talking about a 4-hour window soon after exercise, usually again talking about a carbohydrate protein combination, looking to maximize muscle glycogen and muscle protein synthesis. And then of course it's what does an athlete eat on a daily basis that influences recovery, the second phase of recovery as I've written here, or their change in body composition that might occur in response to training. Now, in terms of fuel use in contracting muscle, I think it's again important to consider where we're coming from with historically. So this is a very carbohydrate and fat centric look at metabolism in muscle, and there's reason for that, which I'll come to shortly. But you're usually talking about circulating fuel sources in the context of free fatty acids or glucose. You also have intramuscular stores of glycogen or of intramuscular triglycerides. These have been mentioned at various times already today. We have these what we call high energy phosphates, the ATP phosphocreatine system. We have anaerobic glycolysis. We have the beta oxidation of fatty acids. We have the TCA cycle coupled to the electron transport chain. So we have anaerobic and aerobic processes. We have, and this actually, you can, yeah, that's fine. That slides, yeah. The major differences between the pathways, aside from their actual, their starting block, so to speak, would be the rate at which they provide ATP. And this is a really important point to make. So if we look at ATP production, or relative power as it's called here, these anaerobic systems produce ATP at a much, much higher rate than the aerobic systems. And equally, the carbohydrate sources that provide ATP as well, they provide them both from glycogen and glucose. Again, it's at a rate slightly lower than the anaerobic pathways, but slightly higher than what's coming from fat. So where it all began, where did we get this carbohydrate dominant perspective on athletic performance? Well, this was a paper published in 1967. It was the first time that the muscle biopsy had been reintroduced in the context of a diet and exercise type intervention. I suppose the interesting thing that wasn't discussed, and it's probably become in vogue a bit more now, is to talk about the inter-individual differences. Clearly some people don't perform that well on the higher carbohydrate diet. They perform as well as they did on the mixed diet. The message around the protein and fat-based diet being sort of an impairment of performance, again, that might be expected when you're talking only about 2 days of adaptation to that diet. The other point here was that this was a time to exhaustion trial. So they get on a bike, they go for as long as they can without stopping, basically until they drop. Very few exercise challenges in performance or in athletic performance are based around that. Most of them are time trial. You either complete the most amount of work you can in a given time, or you try and beat your opponent. Of course, again, this audience doesn't need to be told this, but there has been, of course, increased interest in low carbohydrate diets, and then therefore this has led to increased interest in the ketogenic diet. Now, I suppose, just hit the slide, it's important to note that, of course, again, this audience knows this, but the low carbohydrate diet is, in my mind, metabolically distinct to a ketogenic diet. The whole keto adaptation, what is the time course for that? And I'm being interested to speak to anyone on this outside of this, maybe in the panel discussion. This idea about the 4-week adaptation that's needed. I think there was mention of a 2-week intervention. Jeff has done some 12-week work as well. I really would like to see some evidence that shows this kind of stepwise change that occurs when someone adapts. So we were interested in the question of what happens with 7 days of keto adaptation analysis. So this was a 7-day feed. We did a test pre, test post. We basically did DEX analysis to look at body composition. We did something known as the Fat Max protocol, which is a graded exercise test, 3-minute stages, that allows for the calculation of maximal rates of fat oxidation. So just to advance the slide there. The first thing to note is just that there was about a 2.5 kilo loss of body mass over the course of the 7 days. In terms of what the breakdown was, about a third of that was in the form of body fat. 2/3 of that was in the form of, if you go back, in the form of fat-free mass. The point, of course, here for any of you who are familiar with DEXA is that DEXA essentially is measuring body water, for want of a better word, when it comes to lean mass. So when someone adapts to ketogenic eating, obviously there's going to be a loss of water weight, and that will, in DEXA terms, appear as a loss of lean mass. So just to note that there may have been some lean mass loss, genuine muscle mass, I don't know, but I would take this as mostly being due to the change in water weight. Well, it's not fair to not produce the full picture here, and there's been some harsh critics of this concept. But I'll just read this because this is their opinion. Although adaptation to ketogenic, whether ketogenic or not, increases the muscle's capacity to utilize fat, there is no proof that this leads to a clear performance advantage. In fact, there's a risk of impairing the high intensity exercise performance. So, as I said, just in the interest of fairness, let me just show that perspective. So their message really is that when you look at the Finney work, that okay, the average doesn't change, but if you look at 3 out of the 5 or have impaired performance, 2 out of the 5 are improved. For me, that's, from a practitioner point of view, that's the reality of it. Some people respond well, some people don't respond well to different types of interventions. And as a practitioner, I would have a case-by-case approach. One size doesn't fit all. So I'm not too put out by that piece of opinion. Say that for me, the really exciting area, aside from performance, which is interesting, is this whole question about recovery and adaptation from exercise in elite athletes. We're usually looking to try and do 2 things: refuel for the next training session, or facilitate or promote adaptation to an exercise bout. We do it by 3 main strategies, I would say. Recovery of muscle carbohydrate stores would be the traditional approach, and this can be either maximizing those if we're on the carb-centric type of paradigm for performance, but there's also this question about the train low paradigm, which is that we get athletes to not replenish their muscle carbohydrate stores because that activates signaling kinases and pathways that are more associated with the mitochondrial adaptive phenotype. So that's the train low flow paradigm. We obviously rehydrate, so we use fluids of some kind, and we also look at to stimulate muscle protein synthesis, because this is the process that influences repair and growth of muscle tissue in response to exercise. So to wrap up, take-home messages. So I think endogenous and exogenous ketosis clearly have marked effects on the metabolic response to exercise, but they're very, very distinct metabolic states. Context is paramount. What is the method of ketosis? How is it achieved? What is the degree? So the circulating levels. The training status of the participant is important. The nature of the exercise or performance challenge is also key. Potential mechanisms for enhanced performance are established, but mechanisms for impaired performance are also established. Let's not ignore that. Small changes in performance make really big difference in the success of athletes. So clearly this is an area that should be pursued and optimized. It's no surprise that all of us are so enthusiastic about it. And evidence beyond, say, direct performance benefits, so beyond the bout of exercise, i.e. recovery and adaptation, are for me the most exciting avenues for future research. And maybe we'll get into some of that when we get to our panel discussion. So thanks for your attention. And,